Safety instrumented systems used to be called safety interlock systems. These are systems designed to automatically respond when there is a potentially hazardous situation. For example, a safety instrumented system on this liquid storage tank is composed of a level switch and a solenoid that are capable of shutting down the pump if the level in the tank drops below a critical level. This will prevent damage to the pump. Emergency shutdown systems include sensors and switches, but they also include additional piping and valves and other components. Emergency shutdown systems are designed to shut down, or in some cases, start up parts of a process in emergency situations that are detected by values of process variables. For example, in this gas storage tank, there is a high pressure switch which actuates a solenoid opening a valve that vents the contents of the tank to a flare stack. Both SIS and ESDs rely on components that are entirely independent from the basic process control system. That is, they have their own independent sensors, switches, valves, and piping. When emergency shutdown systems shut down petrochemical processes, usually flammable material is sent to a flare stack, like the one shown here. In the case of a significant shutdown, which may cascade through multiple parts of a process, the flares are designed to accommodate very large flow rates. This flare stack is probably about 100 feet tall, and you can see that the flame coming out of the top of the flare stack is about as tall as the flare itself. Flaring events occurring at petrochemical manufacturing facilities in which many vessels and pipes are de-inventoried all at once, can send material like this to a flare for hours or even days. Often, as the process is starting up again, the streams flowing through different parts of the process may be off-spec until an upstream unit operation comes to a steady state. Often that off-spec material has no place to go. There's no place to store it, you can't put it back in a pipeline, and so you may have to send all of that to a flare. And that's why these flaring events can sometimes last for days when processes are starting back up. Often, these emergency situations are caused by the failure of some component in a process. In the next video, we'll discuss quantitative measures of reliability that can help us to design processes to be less likely to fail.